All right, we already said that magma is going to rise. It rises because it is less dense than the surrounding rock, and that surrounding rock is putting pressure on the magma. So it's going to start rising towards the surface. It can cool along the way and crystallize and form an intrusive rock, or make it all the way to the Earth's surface and escape as lava or ash at a volcano. When this happens, we're taking heat from the interior of the Earth and bringing it to the surface. So it's an important way that the Earth transfers heat out of itself. When that happens, and we have volcanic activity, it's really a way to replenish the Earth because that magma and ash, that new lava and ash is going to have lots of nutrients in it to replenish the soil. It's bringing up water vapor for the oceans. It's bringing gases and for the atmosphere. So a lot is coming up and replenishing some of the surface processes at the same time, releasing the heat. Okay, it rises again because it's got pressure on it. That buoyancy then is going to drive it up to the Earth's surface. This diagram here is a painting of the inside of a volcanic crater like Mount St. Helens, where it was a volcano. Woo, there was an eruption, a crater forms, and now there's a little resurgent cone there in the interior of that volcano. We talk about the movement of magma in terms of a magma's viscosity. Viscosity is, by definition, the resistance to flow. So whenever you hear the word viscosity in your head, think resistance to flow. So a lava that doesn't move very readily has a high viscosity or a high resistance to flow. A hot lava that's flowing really fast has a low resistance to flow, has a low viscosity. The viscosity of a magma depends on the temperature, like the hot, cold honey, but it also depends on the silica content. So the silica, if a magma is high in silica, and we talked about different ways you can change the composition of a magma. If a magma is high in silica, then all those triangles, those pyramids, those silica tetrahedra are going to start touching each other. And as the silica tetrahedra bond to each other, as that magma cools, it's going to make that magma kind of stiff. And so it'll be resistant to flow and have a high viscosity. So silica-rich magmas have a high resistance to flow or a high viscosity. If you lower that silica content, ultramafic, mafic magmas, less of those tetrahedra are going to be bonded to each other, and so it's going to be more fluid.